right, this is the spring semester final review, starting with triangle similarity and congruence. Starting with triangle similarity and congruence, we are going to be looking at the triangles and determining what type of similarity they have by looking at the sides and the angles that they have the same. So this is where we talk about the acronyms, the three letters. We had side, 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 angle, side, angle, side, angle. All right, so those were some of our triangle similarities. Ones that we didn't have were no donkeys, right? And maybe I shouldn't write it like that. Sorry, maybe I should write it backwards. No donkeys, right? Okay, so looking here, looking at our first one, I look at the one with the smallest number of lines. That's a side. Then we go to the left, angle, side. All right, this one, starting with the lowest, we have side. We would have side, side, angle, side, side, angle. And that is a donkey. No donkeys. So this is not similar. No similarity here. Looking at number 2, we have side, angle, side, and side. Oh, I said angle. It's not an angle. Side, 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 and side, side, side. So for this one here, they have side, 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 and all the sides are the same. So these are matching. All right, and for this last one, we have angle, side, angle, angle, side, angle. Those match. So angle, side, angle is similar. All right, moving on to the next one here. Find the measurement of the missing side. So we need to create a ratio and then use that ratio to find the missing side. So on this triangle, we have this side and this side. So we can make a ratio saying 8 over 4. Let's not do that. Let's do the smaller number first. So we'll do 4 over 8, which is 1/2. So then we'll say 10 times 1/2 is 5. So our missing side is 5. All right. So what is the scale factor? Well, it is 1/2. That was the number we came up with. K equals 1/2. Okay. All right. For the next one, find the measurement of the missing side. Let's do this one again. So we have the two sides that both have a number. Let's do the smaller number first. So 12 over 15. When we simplify that, 12 over 15, they're both divisible by 3. So 12 divided by 3 is 4, and 15 divided by 3 is 5. So our k factor is 4 over 5. And then we're going to take that k factor and multiply it by 25. 4 over 5 times 25. It is 20. So if you need to see the work, we said 4 over 5 times 25 equals 20. And that was our missing side. All right, moving down. Sorry for the formatting. It's a little messed up. But this problem on your paper says, what is the height of the flagpole? So just kidding. Find the height of the tree. Here's our tree. We're looking for the height of the tree. So we're going to create a ratio. We're going to say x over its corresponding side, 5, equals 26 over its corresponding side, 6.5. We will cross multiply. We have 6.5x equals 26.5 times 5, which is 130. Now we divide by 6.5, and x equals 20. So this tree is 20 feet tall. All right, number 5. Just kidding, we're still here. Number 5, what is the height of the flagpole? Well, we're going to do the same thing. Height over 5. And then equals to our other fraction, 24 over 8. You have to start with the same triangle. So if we start with this triangle, then on both fractions, we need to start with that triangle. You can't go here, 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 here. Okay, you have to do one triangle in the numerators and the other triangle in the denominator. All right, h times 8 is 8h. 5 times 24 is 120 divided by h. Sorry, divided by 8. H equals 15. So that means this flagpole is 15 feet. All right, number 6, special right triangles. Use properties of 30, 60, 90 right triangles to find the value of U and V. Okay, so if you remember from the special right triangles, when we have 30, 60, 90, the short leg is L, the long leg is L square root of 3, and the hypotenuse is 2L. So this automatically tells us that L is 2. So what's 2 times L? 2 times 2 is 4. So U is 4. And here we have L square root of 3. If L is 2, then we're going to say 2 square root of 3. Oops. 2 square root of 3. All right, easy enough. Let's take a look at the next one. Here we have, well, we'll do number 9 next. Again, a 30, 60, 90 triangle where the short leg is L, the long leg is L square root of 3, and the hypotenuse is 2L. This time they only give us 2L is 16. So if 16 is equal to 2L, we need to solve for L. So we're going to divide by 2, solve for L. L equals 8. Okay, so if L is 8, that means this L is 8, and this one will be L square root of 3. So Y is 8, and X is 8 square root of 3. Perfect. Now let's move on to the 45, 45, 90. In 45, 45, 90 triangles, both legs are the same, and the hypotenuse is L square root of 2. Sorry, my bad. 2. So here it's telling us that L is 9. So that means this L is also 9. And this hypotenuse is going to be 9 square root of 2. Okay. For number 8, same thing. Both legs are L, and the hypotenuse is L square root of 2. They tell us here that L is 20. So that means this is 20, and this is 20 square root of 2. Easy enough. X was 20, this is 20 square root of 2. Perfect. All right, moving on to the trigonometry. Number 10, find x using SOHCAHTOA. All right, well, if we remember SOHCAHTOA, we say SOHCAHTOA. So here we need to identify, this is the angle in question, this is the opposite, this is the adjacent, and this is the hypotenuse. So in this triangle, the only ones that have a number is opposite and hypotenuse. Which one, so, ka, or toa, has opposite and hypotenuse? Sine. So we're going to say sine of our angle, 51, equals opposite over hypotenuse. Opposite is 14, hypotenuse is x. Now, don't copy this down, just watch. If we want to solve for x, our first step would be to multiply both sides by x. Then we would divide by sine to move it over, away from x. This is the same thing as swapping these two. So just to be an easy way out, we'll swap the x and the sine so that we have x equals 14 over sine 51. Now we can type 14 over sine 51 in the calculator, and we get x equals 18.014. Okay. All right, let's take a look at number 11. Again, using SOHCAHTOA. Here is our angle in question. This is our opposite. This is our hypotenuse, and this is the adjacent. The only sides that we actually have numbers for are x, or sorry, opposite and adjacent. Hypotenuse has no number there, so we're not going to use it. So opposite and adjacent, which one? So, no, oh, it's going to be cosine. So we say cosine of the angle equals opposite over A over H. So A is 12. Did I choose the wrong one? Yes. Oh my gosh, you guys are probably like, Miss O, I messed up. Okay, this is opposite and adjacent. That's not cosine, that's tangent. Don't do what I did on the test, okay? Tangent 37 equals opposite over adjacent, so x over 12. In order to solve for x, we will multiply both sides by 12. And now we have 12 tan 37 equals x. And you can type that 12 tan 37 into the calculator, and you'll get 9.04. All right, moving on to number 12. Find the missing angle again using SOHCAHTOA, but now we're looking for the missing angle. When we're looking for the missing angle, we have the inverse. Let's make a note on the side. On the side of your paper, I want you to go like this, maybe not as big as I did, and say missing angle, -1. Up here, we're looking for the missing side, which is just normal, okay? The angle, when we're looking for the missing angle, then we have the inverse, which is the -1. All right, so let's take a look. Here's our angle in question. Here's our opposite. Here's our adjacent. And here's our hypotenuse. We have no number for adjacent, so we're not using anything adjacent. All we have is opposite and hypotenuse. Which trig function has opposite and hypotenuse? Sine. So we're going to say sine -1 with our fraction on the inside, O over H, 12 over 24, equals our missing angle. We'll call that angle X. We can put this in the calculator, sine inverse of 12 over 24, and we get X equals 30. Do we ever enter equals X into the calculator? No, we will never say equals X, type equals X in the calculator. That'll give you an error. All right, last one. Find the missing angle again using SOHCAHTOA. We're using the angle, so we need the inverse. Here's our opposite, here's our hypotenuse, and here's our adjacent. So we have no number for hypotenuse. We only have opposite and adjacent. So which one are we going to use? Cosine. So we have cosine of our fraction, 8 adjacent. Oh, that's, again, I'm messing up on this stuff. It's not cosine. I'm obviously really tired, guys, so I'm sorry. Tangent is opposite and adjacent. So we're going to say tangent opposite over adjacent. So 14 over 48. Oh, and this is the inverse, equals x. Type this in the calculator, and we'll get x equals 9.04. All right. Please see the next video for day 2.